Good evening. Today's quote is again by Bernard Shaw. Without art, the crudeness of reality would make the world unbearable. Today's word is ingenious. If used about a thing or an idea, then it means made or planned in a clever way. Used about a person, then full of new ideas and clever at finding solutions. In the last lecture, we discussed about step function and in fact, three functions we discussed: modulus function, step function, and fractional part function. We will just revise all those functions. What is modulus of x? Modulus of x is x when x is non-negative. Purpose of modulus is to get non-negative answer. So many students think that x is positive and minus x is negative. Not necessarily. X is a real number. It can be positive, negative, or zero. So if it is already non-negative, means either zero or positive, mod x is going to be x only. And mod x is minus x when x is less than zero. Okay. So this is about modulus function. Then step function, greatest integer not greater than x. For example, what is step value of 2.4? Greatest integer not greater than 2.4 is 2. See, basically it is an integer. So either it is 2 or 3. Can I say 3? Can I say greatest integer not greater than 2.4 is 3? No, 3 is greater than 2.4. So it has to be 2. I have already explained this. The simplest method on number line, if you want to find the step value, basically it is an integer. So it is integer which is nearest and to the left of that. I repeat, the integer nearest to that number and to the left of it. It is 2 only. Okay. What is step value of minus pi? That is minus 3.14. Nearest integer to the left. This is minus 3. This is minus 4. So this is say minus 3.14. So what is its step value? Will you say minus 3? No. Minus 3 is greater than minus 3.14. So step value of minus 3.14 is minus 4. So nearest integer to the left. So this is about step function. Then fractional part function. How it is defined? Basically, it is denoted by enclosing x in a curly bracket. So it is x minus step x. So what is fractional part of minus 1.2? As per definition, it is minus 1.2 minus step value of minus 1.2. Now step value of minus 1.2 is minus 2. So it is minus 1.2 plus 2, that is 0.8. And what is the range of this function? Basically, it is fractional part. Okay. So it is semi-open interval 0 to 1. Is that clear? Okay. Now we are in a position to solve sums from which exercise? I have written here exercise 6.2. Okay. So I will again write that. I think 11th sum, we have done A part. Now we have to do B part. This is very interesting. Let me explain. You have to listen to me. Do not write, but please do write after the lecture. Mod of x minus 4 plus mod of x minus 2 equal to 3. Now mod of x minus 4 is either plus or minus x minus 4, right? Similarly, mod of x minus 2 is plus or minus x minus 2 equal to 3. So we have to consider 4 cases. See, which 4 cases? both are say plus. So x minus 4 plus x minus 2 equal to 3. That gives me 2x equal to 9. So x equal to 4.5. Second possibility, both are negative, means minus sign is considered. So minus x minus 4 minus in bracket x minus 2 equal to 3. So that gives us minus 2x equal to minus 3. That is x equal to 1.5. Third case, here plus sign is taken, here minus sign is taken. So we get an absurd result. X minus 4 minus x minus 2 equal to 3. Minus 2 equal to 3. This is absurd. Now fourth case, first is negative, second is positive. This also gives absurd result. So the only two possibilities are 4.5 or 1.5. You can verify. 4.5. Mod of 4.5 minus 4. That is mod of 0.5 is 0.5. Okay. Now 4.5 minus 2 is what? 2.5. What is modulus of 2.5? 2.5. 0.5 plus 2.5 is nothing but 3. Okay. So similarly, we can verify second part also. Exercise 6.2, 11th C part. This is an interesting sum. Solve the equation x square plus 7 mod x plus 12 equal to 0. Now we have to consider two cases. Let x be non-negative, that is greater than or equal to 0. For that, mod x is x. So equation becomes x square plus 7x plus 12 equal to 0. Don't waste time in finding factors. See, in CET, you will not get more than 3 to 4 seconds for this. Immediately you should be able to write x plus 4, x plus 3 equal to 0. So x is minus 4 or minus 3. But x is greater than or equal to 0. So we have to discard both these. You can check. Put x equal to minus 4. Minus 4 square, 16 plus 7 into mod of minus 4, 4. 16 plus 28 plus 12. Is it 0? No. That is why we have discarded that. Second case, let x be less than 0. So mod x is minus x. Equation becomes x square minus 7x plus 12 equal to 0. So I get x equal to 4 or x equal to 3. But we have to discard these two also. Why? We have begun with let x be less than 0. So x can't be these. So equation has no solution. That is solution set is an empty set. D, mod x less than or equal to 3. That is minus 3 less than or equal to x less than or equal to 3. So x belongs to closed interval minus 3, 3. See, I repeat, in exam, you need not write this. In fact, I remember in 10th standard, I was in 10th standard in way back 1986. It was compulsory to do the check part also for the solution. For example, we were required to check the answer. Put x equal to minus 3. Mod of minus 3, 3. Yes, 3 equal to 3. Take any number between minus 3 and 3. Say minus 1. Mod of minus 1, 1. Is 1 less than 3? Yes, like that. So you are expected to do this maybe on the rough page, because in exam it is not required. E part, 2 mod x is 5. So divide by 2. So mod x is 5 by 2, that is 2.5. Now there are two numbers whose modulus value is 2.5. 2.5 has modulus value 2.5. And what is modulus of minus 2.5? 2.5. And therefore plus minus 2.5. Now if we are going to discuss, it is an interesting sum. I'll give you 2 minutes to try the solution and then we'll discuss that. Now this is an interesting sum. Basically there are two possibilities, that x is an integer or x is not an integer. Now why to consider these two cases? For the simple reason, step value of an integer is that integer only. Why? See, basically what is meaning of step x? Greatest integer not greater than x. So suppose x is an integer, say 4. What is greatest integer not greater than 4? 4. 4 itself is an integer. Okay. So the first case, let x be an integer. So step x is x plus x 2x, step 2x is 2x, x plus 2x 3x. What is step 3x? 3x. Because if x is an integer, 3x will be an integer only. But it is given to be 9. So x equal to 3. So this is the first value. You can verify. Step 3, 3. 3 plus 3, 6. Step 6, 6. 6 plus 3, 9. What is the step value of 9? Greatest integer, not greater than 9, is 9 itself. Okay, good. Now second case. Suppose x is not an integer. Let x be any real number which is not an integer. See, every non-integer lies between two integers. Say 7.4. For 7.4, I can say 7 less than 7.4 less than 8. I hope you are getting this. Then there exists m, which is an integer, such that m less than x less than m plus 1. And m is unique, obviously. Now, what is step x? M. I'll tell you. This is not difficult actually. I'll explain this. Just a minute. This bar. Okay. I'll consider particular case. Don't worry. Suppose it is 7.4. Then clearly 7 less than 7.4 less than 8. And I have taken this as m. Okay. So m less than x less than m plus 1. Now what is greatest integer not greater than 7.4? 7. I have explained this at least 10 times. Nearest integer to the left. To the left, not to the right. So that is 7. But here instead of 7, you will notice that it is m. I hope you are getting this. So if m is less than x less than m plus 1, then what is step x? Greatest integer, rather nearest integer to the left is m. So step x is m. So equation becomes x plus step x plus m equal to 9. Now what can we say about x plus 2m? For this, we have begun with m less than x less than m plus 1. Now add m to this. So m plus m, 2m. 2m less than x plus m less than 2m plus 1. Right? I hope you are getting this. And therefore, I can say that this is nothing but x plus m plus x, that is x plus 2m. Now, what is step value of x plus 2m? See, x plus 2m lies between 3m and 3m plus 1. So, step value of x plus 2m is nothing but 3m. Nearest integer to the left, that is 3m. Here, nearest integer to the left of x plus m is what? 2m. That is why 2m here. So, x plus 2m, right? And what is step value of x plus 2m? Again add m to this. So this becomes x plus 2m. It lies between 3m and 3m plus 1. So nearest integer to the left, 3m. So 3m is 9. So m equal to 3. This means x is greater than 3 but less than 4. Okay. So I can say that x is 3 plus r. What is r? R lies between 0 and 1, some fractional part. So from 1 and 2, x is 3 plus r, where it is r is 0, or rather r lies between 0 and 1. Okay. Actually, is this answer correct? Because 3 is also the value. So it should have been x equal to 3 or x equal to 3 plus r, or if you want to combine this, then x equal to 3 plus r, 0 less than or equal to r less than 1, because x equal to 3 is also the answer. Okay. Now G part, fractional part greater than 4. Absurd. Because what is the range of that function? Semi-open interval 0 to 1. 0 is included, 1 is not. So fractional part greater than 4, absurd, no solution. Or solution set is null set, an empty set. Then H, fractional part is 0. So clearly x is an integer, or you may say as per definition it is x minus step x equal to 0. So step x equal to x. Step x is x if and only if x is an integer. You can argue in this fashion also. So actually it is better if you write solution set. So solution set is what? Z, that is set of integers. Now I part. So fractional part is 0.5. So x minus step x. See, this is the standard definition. Is 0.5. Okay. So x is step x plus 0.5. Therefore, x is m plus 0.5, where m is an integer. For example, suppose m is 3. M is 3. So what is step 3? 3. 3 plus 0.5, 3.5. Now tell me, what is fractional part of 3.5? 0.5. Simple. Suppose m is minus 3. What is step value of minus 3? Minus 3. What is minus 3 plus 0.5? Minus 2.5. Now what is step value of, fractional part of minus 2.5? Don't say minus 0.5. Use the definition. It is minus 2.5 plus 3, that is 0.5. Okay. So fractional part is 0.5, means x is some integer plus 0.5. So this is nothing but I think one more is left or what? Okay. So try the next one. Tell me your answer. Type your answer in chat box. Now last part, 2 fractional part x is x plus step x. Now what is the definition of fractional part function? It is x minus step x, but it is 2 times. So 2x minus 2 step x equal to this. Now rearrange the terms. So 3 step x equal to x. Now step x is x by 3, but step x is always an integer. So x by 3 has to be an integer. Now x upon 3 will be an integer if x is nothing but 0. Okay. Now you may say that it can be multiple of 3. No. Suppose you take x as 3. Then what is step 3? 3. 3 into 3, 9. Is 9 same as 3? No. So we can also argue that the only integer whose 3 times that integer is the same is nothing but 0. And that is why x equal to 0. Miscellaneous exercise 6. First question, select the correct answer from the given alternatives. First one, log of 5x minus 9 minus log of x plus 3 is log 2. Then x equal to. See, while solving MCQs, we have to use, or rather we can use shortcut method. You may say check options, or you may say log m minus log n is log of m upon n and so on. But if you check options, you will notice that for x equal to 5, it is log 16 minus log 8, that is log 2, same as RHS. So correct option is B, Bombay. Second one, let me explain. See, basically, right hand side is 0. Log of which number is 0? Log 1 equal to 0. And you will notice that it is log of this to the base 10. So this is 1. So log x to the base 10 is what? 10 raised to 1. So that is why I insist that you should know basics of logarithm. logarithm is the power to which base should be raised. So log x to the base 10 is 10 raised to 1, that is 10. So what is this x? 10 raised to 10, which is given in option B. So this is the second one. Let me explain third also, because fourth is a good one, a difficult one. Degree of difficulty is increased because of the nature of the options. If values are given, then we can just verify the options one by one. But before that, sum number 3. Find x if 2 log x to the base 2 is 4. Actually, we need not use shortcut method. Clearly, log x to the base 2 equal to 2. So what is x? 2 raised to 2, that is 4. Now 4 is given in which option? Again B. So B is the answer. Fourth MCQ, the equation log 16 to the base x square plus log 64 to the base 2x equal to 3 has. Now change the base. I haven't mentioned base initially. It can be any valid base. So as per change of base property, log 16, that is log of 2 raised to 4 upon log x square. Log 64 means log of 2 raised to 6 upon log 2x equal to 3. That is 4 log 2. What is log of x square? 2 log x. 6 log 2. Log mn is log m plus log n. Then I have said that take base as 2. Base could have been taken as 2.1 also. But why to take base as 2? So that log 2 to the base 2 is 1. Now you will ask me, how can we take base as 2? Yes, we can use change of base rule. We can change the original base to any valid base. Perfectly right. So what is the advantage here? So 4 into 1 upon 2 log x plus 6 into 1 upon, what is log 2? Log 2 to the base 2 is 1 plus log x equal to 3. Now for convenience, I have taken log x to the base 2 as y. If you don't like y, you can take z, m, n, etc. But our aim is to find the value of x only. So equation becomes 4 upon 2 is 2, 2 upon y plus 6 upon 1 plus y equal to 3. Now please check this whether this is correct or not. LCM is y into 1 plus y. Numerator 2 plus 2y plus 6y is 3. Cross multiply. Rearrange the terms. See whether we get this quadratic equation. 3y square minus 5y minus 2 equal to 0. So what are the factors? Y minus 2, 3y plus 1 equal to 0. So y is either 2 or minus 1 by 3. Now log x to the base 2 is 2. So x is 2 square, that is 4. Log x to the base 2 is minus 1 upon 3. Is it possible? Yes. Log value can be negative. So x is 2 raised to minus 1 by 3. Actually, there is some ambiguity because in option C, they say 2 real solutions. Yes, that is correct. Option D, 1 integral solution. But still we'll go for option C only. Because when they say 1 integral solution, nothing is said about the second. So we go for option C. Fifth one, f of x is 1 upon 1 minus x. Then what is f of x? Basically, f of x is 1 upon 1 minus x. So what is f of x? Logic is simple. Replace every x by what? 1 upon 1 minus x. Now multiply numerator and denominator by 1 minus x. So 1 minus x upon 1 minus x minus 1. That is this. I have simplified this by multiplying numerator and denominator by minus 1. So x minus 1 upon x. Now f of this, use common sense. F of x is 1 upon 1 minus x. So whatever is written here, it is 1 upon 1 minus that. So f of this is 1 upon 1 minus this. Multiply numerator and denominator by x. So x upon x. Now open the bracket. So minus x minus minus plus 1. So x upon 1, that is x. This is given in option C. That's it for today.